Repetition can be tedious. Performing the same task over and over again can take a long time, and it can be easy to lose track of what you're doing and make a mistake, even if you're repeating a simple task. Take, for instance, repeating simple addition. We can visualize this by building a stack of paper. Let's build our stack by laying down 2 sheets of paper at a time. Each time we lay down 2 sheets, we're adding 2 to the thickness of the stack. We can add a thickness of 2 onto the stack over and over again. Even though adding a value of 2 is a very simple task, it's easy to get lost in the repetition and lose track of how thick the stack of paper is. We're performing +2 again and again. A more efficient way to write the idea of repeated addition is with multiplication. Putting down 2 sheets 20 times could be written as 2 times 20. Now, instead of laying down new sheets of paper, let's build up thickness by taking 1 sheet and folding it in half. Folding it over has doubled the thickness of the paper. Folding it into a second time doubles the thickness to 4. Each fold we make multiplies the thickness by 2. A third fold doubles to create a thickness of 8. And a fourth fold doubles again to make a thickness of 16. Before, when we were stacking on new pages, we were adding 2 again and again. We describe the repeating addition by using multiplication. Now that we are folding the page, we are doubling the thickness or multiplying by 2 again and again. As before, we have a way to condense that repetition into a more convenient form: exponents. We can create an exponent to describe this situation by writing out the number we're multiplying by, in this case 2, and write above it the number of times it's being multiplied, which in this case is 4. 2 is our base number, and 4 is the exponent. We describe this as 2 to the 4th power, or 2 to the power of 4. It's the exact same thing as saying times 2 times 2 times 2 times 2, just in a much more convenient way. Now don't misunderstand this and think that it's describing 2 times 4. 2 times 4 describes 2 being added together 4 times, which equals 8. What the exponent describes is 2 times itself 4 times, which equals 16. Even if we can't see every layer in the folded paper to directly count its thickness, we can see the pattern in how it was made. 2 to the 4th power is 16. Let's see what an exponent would look like with a base number other than 2. We can work with the paper again and fold it into a Z shape to triple its thickness. This kind of fold multiplies the thickness by 3. A second Z fold multiplies the thickness again by 3, giving us a total of 9. A third Z fold triples the thickness once more for a total thickness of 27. Let's describe this process with an exponent. We're repeating the multiplication by 3, so we have a base number of 3. We tripled the thickness 3 times, so the exponent would also be 3. 3 to the 3rd power is 27. This pattern of writing exponents will work for any repeating multiplication. If we multiply by 5 over and over, we can simply count the number of repetitions. Our number 5 is the base, and the number of repetitions is the exponent. 5 multiplied 6 times is 5 to the power of 6. Just as we can use multiplication to condense repeating addition into a simpler statement, we can condense down repeating multiplication with exponents.